All right, we are going to get started. I'm happy to have Tyler Denton from ClearCaptions here. ClearCaptions is a real-time voice captioning technology for phone calls. So they're doing some really, really cool stuff, streaming data in real time, large volumes. I'll let Tyler kind of go into more details on what they do. But happy to have you, Tyler. Thanks.
Thank you. Yep. Everybody hear me? Sounds like it. Cool. So hope everyone's enjoying the conference here in New York. This is my first time in the city, and being someone who lives in the flat part of Colorado, it's quite different. I have to say it's pretty impressive. My name's Tyler Denton. Let's see, how do we do that guy? Yep. I'm a software engineer for ClearCaptions. ClearCaptions provides caption telephone service to Americans who are hard of hearing. We're based out of Roseville, California, and have offices or call centers all around the world. I work in a team of remote developers based in Colorado, but we have developers all over the states. Caption telephone service is much like caption television, only it's live, nearly instantaneous, and must maintain an extremely high degree of accuracy. We provide service to about 50,000 devices, with about 250 typically being used simultaneously. This is a snapshot from a few days ago. Actually, it's not. I'm missing a slide here. This is a snapshot from a few days ago of one of our, just during the middle of the day, active calls. We provide between 100 and 200,000 minutes of caption service every day. And we provide this service through custom home telephones, Android and iOS applications, and a web calling tool that's available in our customer portal. We're funded through the Telecommunications Relay Service, which allows us to provide this service to users and their in-home devices completely free of charge. So if you know anybody that's hard of hearing, you should send them over. You can imagine that getting all these devices to talk to our platform, generate captions from audio, return those captions, and satisfy all the FCC reporting and monitoring and compliance requirements, we have to have a relatively complex system. That system is what I'm going to talk about today. So, some of you might want to know, why is a caption telephone service here at CouchBase Connect? We found a few years ago that our existing database technology just wasn't cutting it. Previously, we used SQL Server, Microsoft SQL Server, and experienced considerable performance bottlenecks. These performance degradations affected the speed and reliability of our entire call processing platform. As an example, it was taking around 3 seconds to establish a caption session and getting worse all the time. As a phone service, in addition to extremely low latency, we also require our database to be highly available, highly concurrent, and geo-redundant. Obviously, that's not something that we're going to get from SQL Server. Change. Our number of users and daily minutes continued to go up, and scaling our platform wasn't meeting the growing demands of our customers. We were seeing significantly diminishing returns on investments. Something had to change. That's where CouchBase helped revolutionize our platform. We have a 10-node cluster that will scale to 13 in the next few months and continue to grow with increased volume. Currently, we have 3 buckets set up for memory-optimized global secondary indexes and are using multiple MapReduce and spatial views. You may have noticed that we've also got the Kafka connector running, probably my favorite part, for replication and eventing. Other than the standard deployment of Asterisk, Camaleo, and CouchBase itself, all of our software is made by our in-house development team. This includes our Akka-based automated call distribution system, our REST APIs, the Kafka consumers, endpoints, agent stations, reporting tools, monitoring, platform testing tools, dashboard, and mapping tools that you saw examples of earlier. What I'm going to do is walk you through how a caption session gets processed through our system and focus on how CouchBase helps us utilize all the data available from that call in our different services. So originally, we were using SQL Server. And all of our customer database and user information was stored in SQL Server. We had to first migrate all of that information out of SQL Server into CouchBase. We did that migration about 2 years ago. And now our customer service reps can directly add users, if a little indirectly, to CouchBase and avoid SQL altogether. So let's take Jim, our new ClearCaptions customer, and register him for caption telephone service. Jim's user profile gets added to our user bucket in CouchBase. The event of making Jim is recorded in our user bucket, and a replication event is sent via DCP stream to Kafka. The Kafka consumer takes this information in the DCP mutation event and creates an entry in a MySQL database that's used by our customized SIP gateway. Looks like Jim's ready to use caption service. Jim picks up the receiver on his nifty new home telephone and gets ready to dial. Picking up the receiver causes the phone to establish a connection to our ACD, the automated call distribution system I talked about earlier. The telephone also attempts to register to our SIP gateway. The gateway checks the MySQL database that we wrote to earlier to ensure that this is a valid user, and if so, forwards the connection onto our to our media servers in our media server cluster. CouchBase then does a similar document lookup in our user bucket to verify that this user is registered and is allowed to use caption service. Very similar to what happened in the SIP gateway with the MySQL database. The ACD uses advanced fraud detection logic utilizing data in CouchBase, including simpler attributes like if the registration is active. The ACD is able to get this information from CouchBase via document ID for near real-time response. The ACD also then generates a document in CouchBase called a call data record. Anybody that works in telecom has probably heard of those. The creation of that document shows up in the DCP stream and is then replicated to our legacy reporting software in SQL Server. The CDR is the central document for tracking our call through our platform. CDRs are used in many of our MapReduce views and spatial views. At this point, the individual caption session has appeared on our call dashboards as a queued call and as a dot on our dashboard map based on the location of our customer. As a reminder, all the customer has done is pick up the handset. We haven't even started dialing a phone number. At this point, an audio session has been established between the phone and our media gateway. As soon as this is established, the gateway tells the ACD about the session, and the ACD starts to look for an agent to caption the called party. Should probably talk about agents here. Our agents use a custom PHP web app called the Agent Station to listen to the audio of the called party of caption session. The Agent Station allows the agent to connect to our media servers as a registered SIP peer, listen to audio, generate captions, and forward those captions on the ACD. When an agent logs in the Agent Station, a document is generated in our CDR bucket. That document is used in a MapReduce view to populate one of our dashboards. That operator session and all the configuration information associated with an operator. Oh.
We lost the projector.
Doesn't look broken. There you go. I'm not sure this will make much sense without the pictures.
I have a question while we're waiting.
Sure.
When you say agents listening to the phone call, is it like a human person or is it?
Yep. So we use,
Be very careful. There's a switcher underneath here.
yay, turns out I kicked it. And it's gone. Oh, he's not even listening. Yeah, so we have agents that actually listen to the audio, and they caption the audio. That's one of the ways we're able to get such fast response time, is that they're actively doing that. Cool. So we've, now I'm lost. So we've generated a document. Document is used in a MapReduce view for our dashboards. The operator session, all configuration, blah, 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 blah. Ah, yeah. So cool part. All that information then shows up as an event in Kafka. We replicate all that information from Kafka through our custom Python consumers into SQL Server for our legacy reporting. Now, the ACD is able to use these CouchBase documents, accessed via document ID, leveraging machine learning to route calls to available captioners. The state machine that tracks this process continuously updates our real-time dashboard through Couchbase's document stores, highly tuned indexes, and views. So recap. Jim hasn't even finished dialing, and we've made multiple Couchbase documents, replicated documents for reporting and compliance, updated dashboards and live maps, queried multiple Couchbase documents, and actually started passing around audio. Makes sense, right? Jim finally finishes dialing. It takes a long time for Jim to dial. Call starts to ring. Called party picks up and says hello. So this is where our platform really starts to work. Our agent and customer hears hello. The text is sent to the ACD. The ACD forwards that caption onto the user, or the endpoint, and updates a Couchbase document via document ID. We record that we sent captions and at what time we sent captions, but compliance prevents us from storing captions unless the user specifically requests us to. And I don't think we have any instances where we're actually doing that. Once again, DCP mutation event shows up in Kafka. Kafka updates SQL Server as fast as possible. But delays caused by SQL Server don't affect the performance of the rest of the platform. This is why we chose to use Kafka as our replication and eventing queue. Keep in mind, we're way before Couchbase was doing eventing. Doing the SQL interaction asynchronously greatly reduces the amount of time it takes for captions to reach the user, but still satisfies our compliance and reporting requirements. Using the CRUD commands in the Java SDK is also considerably faster than the SQL commands that were previously used. Well, what if our agent isn't performing well? As you were just asking, it's actually a human that's doing this captioning, and so they can make mistakes. So we have to have the ability to evaluate and monitor our agents for quality. Evaluators are able to pick an agent at random or target certain agents, and for simplicity's sake, they're going to evaluate Jim's call. Using the dashboard, an evaluator picks Jim's call and starts an evaluation session. This opens a pseudo agent station to view the agent-generated captions and make a connection to our media gateway to listen to the audio. The captions being generated are visible to the evaluator for a comparison to the audio, and the agent is graded based on the agent's speed and accuracy. The evaluator creates a evaluation document that's stored in Couchbase in our CDR bucket. And the evaluator is able to do this in real time while the call is in session. So this is constantly being updated. The report is stored in Couchbase and is edited using nickel queries. Evaluators are also able to review and edit these caption sessions with a Flask web app post-call to edit evaluations, complete evaluations, make notes, things like that. That's also used. That evaluation tool is also used to provide a live dashboard to help evaluators target agents who need to be evaluated that haven't regularly been evaluated, and things like that. Once again, all of this gets replicated to SQL Server via DCP mutation in the Kafka consumers. All right, it's back to Jim's call. This call's been going on for a minute or so. We've updated the CDR for the call for every caption sent, created an evaluation session, created an operator session document, and reported all of this to SQL Server. Let's say Jim finishes his phone call, short call, and hangs up his phone. When this happens, a message is sent to the ACD to close out the caption session, and the audio session ends. The ACD closes out the CDR that we made earlier, tells the agent station that the call is over. The agent disconnects from the call and goes back to waiting for the next call. The operator session document is updated and the agent is reset to available. The dot for this call on the map is removed, and the dashboard is updated to show that the call is over and the agent is now available. All of these changes show up as mutations in Kafka and are replicated to SQL Server. So that's just one of Jim's calls. Now imagine that 200 of Jim's friends start using caption service simultaneously. On a regular day, that comes out to between 15 and 20,000 CouchBase operations per second. That's like during our normal load. That's not a crazy day or anything like that. We've started to move some of our reporting to CouchBase, mostly for verification of numbers in SQL Server, but I think it's a good start. We do this via an application that reviews all of the CDRs for that day from the CDR bucket and compares them to all the entries that were made in SQL Server that day. And it generates a very simple report for the values and differences between those two databases and sends that report in an automated fashion to us. Since you're all here, I'm sure you've gone through the scenarios of why should I choose CouchBase, or why did I choose CouchBase? For ClearCaptions, the answer was pretty simple. We were looking for something that provided low latency, high availability, geo-redundancy, and would scale, for the most part, indefinitely. We knew that geo-redundancy would take us a while to implement, but that we would find it very important in the near future. We also wanted to aggressively accelerate our deployment schedule. The schemaless world of NoSQL supports that. Having to update tables and go through DBA reviews, etc., cause significant bottlenecks to our platform updates and changes. Moving to CouchBase brought the database under the control of the developers. Now changes can happen in an agile fashion with limited resources and high availability, and high speed. We also wanted the ability to easily scale the database to support additional traffic. Doing that in other database technologies is extremely expensive in both capital expenditure on licensing and labor costs in the actual cluster modification. With CouchBase, we can spin up new nodes or take them down in minutes. It's even possible to automate that process. I think there was a couple seminars on that actually today. And the fact that different services can be scaled independently through multidimensional scaling puts CouchBase leaps and bounds over the other technologies we evaluated. The learning curve for CouchBase's query language is also not very steep. NCL is something very easy for people already familiar with SQL to use. NCL is a SQL-compliant query language similar to what you use in any other relational database. This made it very quick to try out. And since CouchBase doesn't require ODBC or JDBC drivers, evaluating it is extremely easy. When upgrading our platform to CouchBase, there were multiple unexpected growing pains. We knew that we would have to update all our software to work with CouchBase as opposed to working with SQL. What we didn't expect is that this process would take us 6 months to get to a point where we could have CouchBase in production. After about a year, we were no longer moving functionality from SQL to CouchBase, but only adding additional functionality we previously lacked. CouchBase support was a huge help with us, but it was still a very difficult process. We also had multiple iterations of the actual CouchBase cluster. Originally, we tried having all 3 services on each node and scaling horizontally. Moving to multidimensional scaling was an enormous step up for us in terms of performance and scalability and reliability. But from an infrastructure perspective, it's kind of a huge change. Our recommendation is if you're moving to CouchBase is to just start with multidimensional scaling. This is particularly important when moving CouchBase into production. It's not fun to try and move your cluster from horizontal to multidimensional scaling after deploying to production. Until recently, we also continued to have issues with data integrity between Couchbase and our legacy reporting systems. Since they're relational databases and have fixed schema, updating Couchbase documents often leaves data missing from SQL. We do our best with Kafka to ensure data is flowing cleanly from Couchbase to SQL, but that's not always the case. Previously, our applications tried to update both databases, keeping all info possible in Couchbase while reporting only what was absolutely necessary in SQL. This means anytime we had a service restart, we would lose data in the process of being written to SQL. Then validation between SQL and Couchbase would be off. Other areas of data integrity came up when migrating data from SQL to Couchbase. Iterating through countless SQL records, turning them into JSON documents, and then pushing them to Couchbase was a much bigger project than anticipated. And then validating that migration was successful without data loss was another very large project. Looking forward, we're very excited about version 5.5. Well, really, we're looking forward to 5.5.1, but either way. Moving from 4.5 to 5.5 will allow us to set up specific users for each application. We're really hoping that at some point, the mutation events that show up in Kafka for each mutation will include the user. Haven't had a chance to play with it yet, so I don't know if that's the case. But that would apply for much more thorough auditing. The new version of Couchbase also has this fancy eventing API, which can be very useful for events that we don't currently capture in Kafka. Having a complex cluster like we do, managing our indexes is also very complicated. In version 4.5, we were required to manually manage index replication. Going forward, the new version of Couchbase handles this replication itself. This new method of indexing allows us to lose index nodes, and the indexes will rebalance on their own. This results in a much more reliable and resilient database, also simplifies the process of adding and removing index nodes, and reduces the number of automation scripts I'm required to maintain. Our goal as a company is to add multiple data centers that are located around the country and decrease the routing time for calls and captions. Couchbase's XDCR will allow this, and we hope to have this in place next year. And just like the rest of us, we're very much looking forward to the GA release of Couchbase Analytics. This project looks very promising and should help us move away from our legacy reporting system and into reporting directly from Couchbase. Analytics should give us a much greater insight into our platform's performance. And that's Couchbase. Any questions?
Questions for Tyler? Yeah.
Was your infrastructure on-prem or?
Go ahead and say the last one.
Was your infrastructure all on-prem or
Yes.
cloud hosted?
No, it's all on premises. At least our production environment.
You don't store the actual text, right? The speech.
We are not allowed to store any of the actual captions.
Okay.
So we're not allowed to store the audio, and we're not allowed to store the
So you
the
store a
captions.
link to it wherever that is stored in Couchbase.
Um,
The paths to.
No, we store that captions were sent, how many captions were sent, and the time.
Okay.
So we're able to audit that we're actually sending captions and that we have something that shows that captions were sent, but we don't actually have the content of the captions.
Okay.
I think that'd be a pretty big privacy problem.
Yeah.
What's the necessity to have an on-premise? Why can't this be a cloud solution?
You have to ask my boss.
Is there a technical reason or?
So because of what we're talking about with captions and moving audio around and privacy and things like that, the rule is that we have to be in direct control of all the data. And so if we were to put that into a cloud, it makes a question of, are we actually the ones in control of that data? Because we don't own that hardware. It's somewhere else. It's not ours.
Is your question, is there a technical limitation with Couchbase to run in the cloud? Is that the question, or was it
Yeah, no, I mean, more of a business use case.
business use case? Gotcha.
Could this be put on the cloud?
I mean, the platform would run fine in the cloud. It's just compliance prevents us from doing it.
non-production environments,
I think they'd laugh at us if we went to them with them. Can you sign this? I wouldn't even know who to give the paper to.
But the CouchBase technology itself can run in all the major clouds are provided, and in fact, we announced a managed cloud service offering this morning. That's a new offering for supporting cloud.
Yeah, we have a 10-node cluster and a lot. Yeah, and we've got 2 4-node clusters in our dev environment now, which are both in AWS.
And also another question. You have humans actually translating or not, transcripting the audio
Yep.
text. Have you considered machine learning using NLP to, I mean, we use like Dragon naturally to do speech to text, right? So is that something that could be done?
Well, it's something to think about is we're not even allowed to host our data in the cloud, right? So using cloud-based ASR is a very difficult thing for us to try and do. It's something that we would love to do, but it's up to the FCC at this point to allow it.
Hello.
Humans are more accurate than ASR right now.
Very much more accurate.
We run typically about 95% plus accuracy of caption. If you ever watch a live TV stream, it works way better than that.
It's totally different. Yeah.
That's essentially what ASR would get, automated speech recognition. You'll get words that are way off. Our customer base, older demographic, right? They want accuracy. They want speed too, but more about what was actually said. May have said this. They want the action.
What's the benchmark? Human is 95%.
We have our own evaluation, our own operational QA team.
Mhm.
Rates all these agents in real time. They're all, because we're doing it during the call, we can remote in with Moppy, but sorry, that's I can get remotes in.
What?
The other 2 remotes in listens to the audio being spoken and sees the captions that the agent is voicing and grades them. So we have historical data.
You're next. If Wes stops.
We have another question.
It's okay.
That's great.
it's
info. Yeah,
okay.
I just want to make sure she got her question.
Hello. In regards to monitoring and evaluating your customer calls for the representatives, do you currently or are you thinking about in the future incorporating tone recognition and into your platform just to ensure that the call representatives everything's going successfully?
So
as far as your
what kind
representatives?
of recognition? I'm sorry.
Tone recognition.
Tone recognition.
Yes.
So there's only a couple engines that provide tone recognition. And once again, they're cloud-based. So it's something that we would love to do. It's something that IBM Watson would be able to do for us very, very well. But until they're willing to host a secure Watson service, it's not something that we're going to be able to do. I mean, we can demo it, we can develop it, we can write all the code for it. But until IBM is willing to provide that service for us, there's not much that we can do.
Thank you.
Yeah.
Other questions? All right. Thanks, Tyler.
Yeah, thank you.
Good stuff.